Hi everybody, this is Ms. Boykin with my last video of the night called Multiplying and Dividing Radicals. This time I thought I would include multiplying with some roots higher than a square root, so we have some cube roots here that we're working with. Well, remember before, what's outside a radical gets multiplied by what's outside a radical, being that we have like radicals. So the -5 and a -5 make positive 25. Now we're going to multiply the 216 times the -30. And we're going to get the cube root of 6,480, and then of course n times n squared, same base, add the exponents, n to the third. So here we go. We now need to simplify the cube root of this very large number. So let's first work on simplifying the cube root of 6,480. I'm going to come down and use my TI Inspire. The trick I taught you in Desmos.com or using our TI Inspire calculator is we go to the graphing app and we're going to put in there that very large number, -6480. And it's a cube root, so we're going to divide by x to the third power. It's a cube root, so we're going to divide by x to the third power. The opposite of the cube root is x to the third. Hit enter, go look at our table, Control T, and this is the trick where I taught you. Now we never want to leave a negative under the radical sign, so let's scroll backwards, and this way our negative is going to be outside the radical. And as I taught you before, we're going to scroll until we find a decimal that begins with 0, and here they are. Now I can start working towards 0, looking for, I guess I really scrolled past those zeros, didn't I? There we go. For our first occurrence of whole numbers in both columns. And here we are, -6 and 30. So that's going to be the simplification. The -6 is going outside, the 30 inside. So let's go back, and this is going to be a -6 cube root of 30. Now don't forget, we still have to multiply it by our positive 25 that we calculated from earlier. Now we're going to take the cube root of n to the third. The cube root of n to the third. Now remember I said if we can make 3 of them, we can pull one out. N times n times n. Yes, indeed, we made a set of 3. We can pull one out. The other way I told you to simplify your variables with exponents is n to the third power, and the index in the ditch becomes the denominator. 3 divided by 3 is n to the first, just like we could only pull out one n when we made a triple. So we're going to pull out also an n with no n remainder. Now our job is to multiply 25 times a -6, and we're going to get a -150 n cube root of 30, because a cube root of 30 cannot be simplified any further, and this would be our answer. Alrighty, let's go on to our next one. Okay, just like before, we have 2 cube roots we're multiplying together, so let's begin by multiplying a -7 times a -6, and we get positive 42. And the cube root, we're going to multiply what's inside times what's inside. So 72 times 30, 2,160. X squared times x to the fourth, same base, add your exponents. That would be x to the 6th. Alright, that's my dog. Sorry. Let me pause to let her out. So let's go over to our TI Inspire and put the cube root of 2,160 in there. (2,160) divided by, it's a cube root, so the opposite would be x to the third power. Control T. This time we have a positive number, so we don't have to worry about it. And we're going to go down and we're going to look for where the decimal begins with a 0, and here it is. Scroll back to see where I find the first occurrence of a whole number, and here we go. 6 on the outside, cube root of 10. So 42 times 6 on the outside, cube root of 10. But don't forget we got the variable here, x to the 6. And remember I told you if we took this index number and made it my denominator, we can see 3 goes into 6 2 times, so that makes x squared with nothing left over. So we don't need to put anything under the radical. My very last step is to multiply 42 times 6, and I get 252. X squared cube root of 10 would be my entire answer. And there you go. Let's take a look at the next problem. Alright, this is where we begin our dividing radicals. Now, one of the main rules in math is to never leave a radical in the denominator. Doesn't matter if it's a square root or a cube root, we got to get rid of it. And how we get rid of it is we're going to multiply by whatever that radical is. We're just going to multiply by that. So we're going to have the square root of 20 divided by the square root of 5. So to get rid of it, I'm going to multiply both the top and the bottom by the square root of 5. Basically, all I'm doing is multiplying it by 1, because anything divided by itself equals 1. So I've not changed the radical per se. We're just going to get rid of the radical in the denominator. So the square root of 5 times the square root of 5 is the square root of 25, which equals 5. And so you notice how the radical is now gone. On the top, what's under the radical sign gets multiplied by what's under the radical sign. So now we have 20 times 5 is 100. 100 happens to be a perfect square. Square root of 100 is 10. Never leave a fraction unsimplified. 10 divided by 5 is 2. And there's your answer. You could also check this in your calculator by putting the square root of 20 divided by the square root of 5 and check your answer and make sure it matches. Not all of them are going to work out as easily. We might still have some with radicals in the numerator. Okay, let's take a look at our next problem. With this problem here, we do have a radical in the denominator. I don't worry about simplifying it. I just get rid of it. So we're going to multiply by the square root of 12 divided by the square root of 12. You might be asking, why didn't I put the 3 in there? Well, it's not underneath the radical sign, so why make it even more complicated? So I'm going to multiply 3 times the square root of 12 times the square root of 12. Well, 12 times 12 is 144, and the square root of 144 is 12. So basically, when you're multiplying by the same radical, you get the number and forget about the radical sign itself. So this is going to be 3 times 12. And in the numerator, we're going to do 2 square root of 15 times the square root of 12. What's outside gets multiplied by outside, and 15 times 12 is 180. Okay. So let's go ahead and get this simplified. 3 times 12 is 36. Sorry about that. Let's get back to my pen. Okay, a little technical difficulty here. There we go. 3 times 12 is 36, and we need to simplify 2 square root of 180. So let's take a look at what square root of 180 is in the calculator. I'm going to clear out some of my calculator screens here. And we're talking about 180. And we're going to take the square root of that. So we're going to divide by x squared. Control T. And let's scroll down to find our decimal beginning with a 0. There it is. We're now going to scroll backwards till we find the first occurrence of a whole number, and there it is. 6 on the outside, 5 on the inside. all over 36. So now 2 times 6 is 12 square root of 5 all over 36. But wait, we're not done. Let's take a look at how we can simplify 12 and 36. Well, I know that 12 times 3 is 36, so we can say 12 divided by 12 is 1, 36 divided by 12 is 3, and so therefore our final answer is a square root of 5 divided by 3. If you want, you can put 12 divided by 36 in your calculator, and it will simplify it for you. It will tell you 1/3, but don't forget that radical 5 was part of my numerator, so please don't leave it out. There you go. All right, well, let's take a look at I think this is our last problem, maybe second to last. Once again, we have the square root of 3 minus 3 all over 2 square root of 14. Let's get rid of the radical in the denominator. We're going to multiply by the square root of 14 divided by the square root of 14, which equals 1. And this time we have to multiply the square root of 14. We have to distribute that to both terms. So we have 14 times 3, or should I say 14 times 3 because they're both on the radical, is square root of 42. And square root of 14 times the negative 3 is a negative 3 square root of 14. Now I know by multiplying the square root of 14 times the square root of 14 and then taking the square root of it, I'm going to get 14. Okay, so let's keep going. And we now have the square root of 42 minus 3 square root of 14 all over 2 times 14 is 28. This cannot be simplified. The square root of 42 cannot be simplified. Neither can the square root of 14. It's 7 times 2. None of those are a perfect square. So just make sure that your radicals are fully simplified. If we wanted to double check that square root of 42 in the calculator, feel free. Doesn't hurt to double check. Wouldn't be the first time this boy can make a little error, right? So Control T. At least I'm honest, right? Okay. And going down, I find my 0. Scrolling backwards, other than 1 and 42. See, there's no combination that I can simplify the square root of 42. So this would be my fully simplified answer. All right. And my last problem. Okay, this is one where we have a little special rule that we need to take into consideration when we do these, and that is where we have two terms here. One is a radical. Well, you know you can't keep that radical under there. So whenever you have two terms, they say we must multiply by the conjugate. Fancy word, conjugate. And basically, when you multiply by a conjugate, the terms are going to remain the same. The only difference is going to be the sign in the middle. So we can say the conjugate of 2 square root of 2 plus 4 is 2 square root of 2 minus 4. That's the conjugate. And whatever you multiply the denominator by, we can't change the value or multiply the numerator by the same thing. So we always multiply by the conjugate. So here we go, we need to multiply. Now on the bottom we have a binomial times a binomial. We're going to have to use the box method. Here we've got 2 times a binomial. We're going to have to do the distributive property for that. Boy, we've got our work cut out for us. Whew, let's go. 2 times 2 is 4 square root of 2. 2 times a negative 4 is a negative 8. Now for that box method. Over here we're going to do 2 square root of 2 plus 4, 2 square root of 2 minus 4. I think after I get this problem done, I have to call it quits. All right, here we go. 2 times 2 is 4. Square root of 2 times square root of 2 is the square root of 2 times 2 is 4. Square root of 4 is 2. 4 times 2, that makes 8. Do a little simplifying and I circle it. All right, let's do this one. Positive 4 times 2 is a positive 8 square root of 2. Outside times outside. There's no inside to multiply. Here we go. Negative 4 times 2 is now a negative 8 square root of 2. And you can see we got a negative 8 square root of 2, a positive 8 square root of 2. Those are going to cancel out. They're going to equal 0. And then positive 4 times a negative 4 is a negative 16. So what do we have? We have 8 minus 16. 8 minus 16 is a negative 8. Okay. Now, here comes the tricky part. We don't ever want to have a negative sign in the denominator. We're going to move it up. And if we put it up in our numerator, we just can't put it in front of this, but it's like a negative 1 that's going to get multiplied by both these terms. So a negative 1 times 4 makes a negative 4 square root of 2. Negative 1 times negative 8 makes a positive 8. And then by moving it up, it's no longer in my denominator. So that's one of the rules we have to remember. Float that negative sign up to your numerator. My last step is to simplify. Now we got to be careful here. What we need to do, these are basically two terms being divided by 8. So this term is being divided by 8, and this is also being divided by 8. So we have to be careful there. So, what number can 4 and 8 and 8 all be divided by? Well, they all can be divided by 4. So negative 4 divided by 4, divide by 4, divide by 4. All three parts have to be divisible by the same number. So let's see what the final answer is. Negative 4 divided by 4 makes this a negative 1, or just negative square root of 2. 8 divided by 4 is 2. And in the denominator, 8 divided by 4 is 2. And this is your simplified answer. Again, I cannot stress enough, what's on the outside gets simplified with what's on outside. Notice I didn't touch the 2. He's on the inside. The negative 4, the 8, and the 8 all had to be divisible by the same number to further simplify this. 2 out of 3 is not good enough. So once I found out what I could divide by, notice I wrote it down on all 3 of my parts so that I can go through the steps one by one. So this is probably the most complicated type of radical problem when you get into division, multiplying by the conjugate, remembering to float negative signs up to the numerator, and I don't care what kind of problem we have, float negative signs up to our numerator, and if there's more than one term, it's like multiplying by a negative 1 to all your terms, and then remembering always to simplify. Well, that's my last problem of the night, guys. I gotta call it quits because 5 o'clock's coming awful early. If you have any questions, feel free to see me in Cab Morning. Have a great night.